This video will go over Chapter 9, Section 1, numbers 1 through 16. Number 1, the area of the parallelogram. Base times height is our area formula here, so we just take 12 times 10, and our answer is 120 centimeters squared. Number 2 requires applying the area formula in reverse. So if base times height is area, we can plug in for the base and the area. And to find the height, we can divide both sides by 2x, and our height is going to be equal to 5x feet. Number 3, the perimeter of a square in which the area is 169 centimeters squared. So the formula here for area is equal to side squared. So if our area is 169, I just square root it to find s. And it turns out that s here is going to be 13. So picture a square, and the side lengths are 13. If I wanted to find the perimeter, I just take the side length times 4, or 13 plus 13 plus 13 plus 13, 52 centimeters is the final answer. Number 4 is about the area of a trapezoid. The area formula is found by taking the average of the two bases, or base 1 plus base 2 divided by 2, and multiplying that by the height. Our trapezoid here is turned, it's rotated. The bases are in red, and the height here is in blue. So if I substitute in these values, I get that 24 divided by 2, which is 12, times 20 is my area. And that value is 240 meters squared. Formula for area of a triangle, base times height divided by 2. So if I plug in what I know, the next steps are to multiply by 2 to cancel out this side. Then I can divide by 9 on both sides. This gives me 13. That's the base of the triangle. I guess I could say 13 inches. So for number 6, I'm going to use the trapezoid formula again. I'm going to replace what I know. For example, I know that B2 is 9x plus 12. I know that my area is 48x plus 68. And finally, I know that my height is 8. From here, I have several options. I might choose to simplify 8 divided by 2 and just call that multiplying by 4. You don't have to, but you could. And then you would divide everything by 4. This leaves you with 12x plus 17 is equal to base 1 plus 9x plus 12. I might subtract 9x from both sides and subtract 12 from both sides. My final answer is that base 1 is 3x plus 5. Number 7 asks for the area of the rhombus. And to find the area, I would need two diagonals. I know one of them. This diagonal here is 14. I could plug that in. But I have to figure out the other diagonal to solve this problem. We learned earlier in the year that the diagonals of a rhombus bisect each other, which means this diagonal 14 inches is cut into two equal parts of 7 each. And what I've done now is I've created these right triangles. So I can use this 25, which is my hypotenuse, to figure out what this value is going to be. And if I apply it twice, I can figure out my diagonal. So I'm going to use Pythagorean theorem, a squared plus b squared equals c squared, and I'll replace the values like so. I'm going to move the 7 squared over by subtracting, and I'll take the square root of both sides. It turns out if I do this in the calculator, if I take the square root of 25 squared minus 7 squared, I get 24. Which means in my diagram I can replace these x's with 24s. So if I go back to my formula, diagonal 1 times diagonal 2 divided by 2, now I know my diagonals. One of them is 48, that's 24 plus 24. The other one is 14, that's 7 plus 7. And I divide this whole thing by 2. My final answer is 336 inches squared. Number 8 uses the same formula. This time it's for a kite, but they share the area formula with a rhombus. And I can plug in my known values. And here all I have to do is multiply by 2 and then divide by 15. So there I multiplied by 2, and here I divided by 15. The other diagonal is 25 meters. Number 9, same formula. Looks a little different because of the variables and the exponents. First thing I do is I multiply both sides by 2. So times 2 over here, times 2 over here, and this cancels out. So that 12 becomes a 24, and nothing else really changes on the left. Next, I divide by 3xy. Now this might look quite complicated, but it's actually not as bad as it looks, because 24 divided by 3 is 8. And when I see x squared divided by x, that just means I take the 2 minus the 1, and I'm left with x to the first power. And for the y's, it's y to the third divided by y to the first, so you subtract 3 minus 1, and you're left with y squared. And there's your answer. For number 10, let's consider these blue pieces first. Each individual square has an area of 1. Because the dimensions are 1 foot by 1 foot, 1 times 1 is 1. Then these triangles, 1 times 1 divided by 2, so it's going to be 1/2. So 1 plus 1/2 for each blue piece. 1.5 feet squared, and they're both the same size. Next up, the green, we have 2 complete squares, so we're just going to say 1 plus 1 is 2 feet squared. As far as the orange goes, I have a triangle with a height of 2 and a base of 1, so this is 2 times 1 divided by 2, which is just going to be 1 per triangle, 1 feet squared. Last up for the yellow, if I consider this my height and base for a triangle like this, I can just double my answer and figure out the area of the whole thing. So the height is 1, the base is 3, I divide this by 2, and then there's 2 of them, so 3 feet squared for yellow. And if I was to count up 2 of these blue ones, 2 of the green ones, 2 of the orange, and 1 of the yellow, I get 12. So I did something right, because 4 times 3 is 12. For 11, parallelogram, area equals base times height. So 7.5 is equal to 6 times h. Divide by 6, my height is 1.25 meters. So one way to write the perimeter is 2 times the base plus 2 times the width, or sometimes we use length and width. And if I plug in those values, it looks like this. I have to remember to distribute to all parts of the binomial, and then I just combine like terms. 4x plus 2 inches. So for 13, the area of a parallelogram is base times height. So I'm going to put the base, 3x plus 5, here, and the height, 7x minus 1 here, and I can multiply row by column. 21x squared, 35x, negative 3x, and negative 5. And notice when I combine like terms, these are my x terms. So my final answer for the area is going to be 21x squared plus 32x minus 5 feet. 14, area of a triangle is going to be base times height divided by 2. So the tricky part here is trying to figure out which one is which. We have 3 different numbers here, and it turns out 15 is going to be my height. Notice the 90-degree angle, that tells me which one is my height. And how could I possibly figure out my base? I'm going to have to work for it, because they don't give it to me. So if I consider this a right triangle, the missing leg is going to be the square root of 25 squared minus 15 squared. So that value is going to be 20. And over here, I'll take the square root of 17 squared minus 15 squared. And that value is going to be 8. So adding these two distances together gives me my base, 28. So I can replace base and height with 28 and 15. My final answer is 210 inches squared. So I can replace in my area formula for a trapezoid all of the values that I know. And 8 plus 20 is 28. Divide that by 2 and I get 14. Here, if I divide both sides by 14, my height is going to be 20 centimeters. So for 16, I take base times height divided by 2. X plus 1 times 8x all over 2. So if I distribute this, 8x squared plus 8x all over 2. So my final answer, once I simplify, 4x squared plus 4x feet.